So when we're given a difference quotient that says f of x plus h minus f of x over h when h is not equal to 0, they'll give us a function and they'll want us to figure out the quotient from that. So in this case, let's start with f of x equals 2x. Now before we sit there and start to substitute in, if I give you f of x equals 2x, I could also say f of x plus h is 2 times x plus h. And all I did there is whatever was in the parentheses for just x is now 2 times x plus h. So, replaced with the x plus h, we could even simplify that and call it 2x and 2h. So now if we take those portions of it, we're really looking at three things. We're looking at f of x plus h, f of x, and h. So I'm going to put all those pieces together, and I get 2x plus 2h minus my f of x, which is 2x, over h. Now, I'm going to simplify. I have a 2x and a negative 2x, and I'm left with 2h over h, which simplifies to become 2 when h is not equal to 0. Okay, that's our first difference quotient. Let's do another one. Let's say now it's 3x minus 1. So we're looking for f of x plus h minus f of x over h, when of course h is not equal to 0. So before I even get to that, I'm going to rewrite f of x equals 3x plus minus 1 as f of x plus h. And that becomes this new term, which we'll rewrite as 3x plus 3h minus 1. Let me move this over here. Okay, so I kind of saved myself the time. Now I could just plug in this first to the whole thing, but why not simplify? Maybe it'll make it easier for us. So I'm going to put in 3x plus 3h minus 1 minus the quantity 3x minus 1. Don't forget that negative. You have to distribute it to the second term. So now we get 3x plus 3h minus 1 minus 3x plus 1, because it's a minus a negative, over h. So we hope it simplifies. Let's see. I have a negative 3x and a positive 3x, a negative 1 and a positive 1. So it looks like I'm left with 3h over h, which becomes simply 3, and again when h is not equal to 0. Now why we need h equal to 0 there, might as well mention it now. If h was equal to 0, we'd have an undefined term from the beginning, and it wouldn't work. So, let's do another one. A little bit more of this. This time, the difference quotient they want, our function is x squared minus x plus 1, and the difference quotient they want is now 2 plus h minus f of 2. So, let's kind of put some pieces together. So I know f of x is x squared minus x plus 1. So instead of substituting it all in, why don't I just figure out all the possible parts I might need? So I know I need f of 2. Well, f of 2 is 2 squared minus 2 plus 1, which is 4 minus 2 plus 1 is 3. F of x plus h would be x plus h squared minus x plus h plus 1. Now instead of simplifying that, I realize it's going to be eventually a 2 plus h. So I'm going to replace all of the x's with a 2. So I have 2 plus h squared minus 2 plus h plus 1. Now this one I got to simplify a little bit more. If I know my difference of, or my squaring a sum, I know it's going to be the square of the first, that's 4, plus 2 times 2 and h, so that's 2 times 2h, plus the last term squared, minus 2 minus h plus 1. So what we're left with here is a rather long term, which we could actually simplify a little bit, because I have 4 minus 2 plus 1. and I have a 4h. So let's get some things out of the way here. 4 minus 2 plus 1 is 3. So these are taken care of. 4h minus h is 3h, and then h squared. So let's kind of shrink this stuff down. I got all these pieces that I need. Actually, I only need 2 of them. The ones I need are f of 2 and f of 2 plus h. So I go up and I'm going to do my quotient, which is f of 2 plus h minus f of 2 over h, and that's of course when h is not equal to 0. I'm going to plug in the pieces that I have. I have 3 plus 3h plus h squared. I have f of 2 is 3, so minus 3 over h. Now this is a lot easier than writing it all in the fraction and then simplifying out there, and I could have done that. In some cases it will be nice just to put it into the fraction and simplify it from there, but we have a lot of pieces here. Let's kind of try to clean up. So I have a 3 and a negative 3. That leaves me with 3h plus h squared over h, which I can factor out an h, and I get 3 plus h over h. My answer becomes 3 plus h when h is not equal to 0. So let's do it. So now we're looking at the function x cubed plus x, and we're going to do the difference quotient for that one as well. So we already know f of x, and we're going to need that one. But the other one we need, which we need to pay a little bit of attention to, is that x plus h. So that's where we have x plus h cubed plus x plus h. Now this one's going to take a little bit of work to get through, but it's just multiplying out our binomial. So the first way we want to think of it is that is 3x plus h's. So you're basically expanding it out, and then you're going to add an x plus h onto the end. So if I do 2 of them together, x plus h times x plus h, that is a square. So I get x squared plus 2xh plus h squared. Then I still have one more x plus h to go, plus x plus h. Now, if you're not remembering how to do this step right here, you could use FOIL, you could use the box method, you could stack them and multiply them vertically. I'm just multiplying the 2 of them together. And then I'm going to go through and do the same thing now for the x squared plus 2xh plus h squared and my other x plus h. So I multiply those out, and just going with like a FOIL approach by multiplying all of these by x and then multiplying them all by h, which is essentially what we're doing. I'm then going to combine like terms, and we get to x cubed plus 3x squared h plus 3xh squared plus h cubed plus, again in the end, x plus h. Now you may be looking at that. That is a Pascal's triangle binomial expansion. We did that a little bit as well in Algebra 2. But in either case, we got what we need. I looked through. I can't really combine any more of those terms. It's set as it is. So that is my f of x plus h. So I'm going to get rid of some of this just to save space. I'm going to cut that out and move this up. So now I have the 2 parts that I need. So it's going to go into my difference quotient of f of x plus h minus f of x over h. Let's change colors here. So I'm going to take all of that f of x plus h, since, well, I don't want to rewrite it again. I can copy and paste it. Looks like I grabbed an extra parenthesis. Let's shrink this down. So as you might see, these will may take up a little bit of paper space. Alright, so that's f of x plus h. Got to remember on the end I have to subtract x cubed plus x, and that's over h. Now, to make it a little bit nicer, I'm just going to change that end piece. And you should just rewrite this as a new line, but going to distribute out the negative. So let's get rid of some things. I have x cubed, negative x cubed. I have x, I have negative x. So now we can write it down here. I have 3x squared h plus 3xh squared plus h cubed plus h over h. Now this is very nice because everything has an h in it on top, so I can factor out an h, and I get 3x squared plus 3xh plus h squared plus 1 over h. And this gives us our answer. We get 3x squared plus 3xh plus h squared plus 1, and that is when h is not equal to 0. So we're going to do one more here, and this one's a little bit different, but it's still following the same idea. So it's not that we're getting stuck in this specific difference quotient. We want to give ourselves the opportunity when different problems arise to still solve it. So when I look at this one, I need to know f of t, which I do is 1 over t, but I need to also know f of 1. Now f of 1 is 1 over 1, or 1. So I get that the difference quotient I'm looking for here, if I fill in the pieces I know, now before I get too far, realize why it's t doesn't equal 1, because that gives you a 0 in the denominator now that we have a t minus 1. But I put in my functions. I have 1 over t minus 1 over t minus 1. Now if I'm going to simplify this, I'm going to turn that top fraction into one term, or the fraction minus 1. And that's because, or what lets me do it, I should say, is 1 over t minus t over t minus 1. That's because, well, t over t is 1. We now have 1 over t, let's go 1 minus t over t for t minus 1. Now if I bring that down, we're going to actually do a little bit more before we get to our final division here. Oh, copied it down wrong. Let's go here. I have 1 minus t and I have t minus 1. They're very close to each other. If I actually take a negative 1 out of the top value, it becomes t minus 1. And that's going to be something we'll probably need, because you notice now I have those t minus 1s. So really I have a fraction divided by a number. I like to turn this into a division problem. Negative 1 t minus 1 over t divided by t minus 1. Now, as you've known for years, whenever you have a division problem like this, you flip the second fraction or second term, take its reciprocal, and that turns it into a multiplication problem. And then by doing that, I now have t minus 1 and t minus 1, and when I multiply through, they reduce, and I get negative 1 over t when t doesn't equal 1. So it's a little bit different approach, but we still use that same idea of rewriting a function, plugging them in, and simplifying.